Okay, so today we're going to do some questions on qualitative graphs. We have 7 examples. We'll start with example number 1. So what we're going to do is we're going to read this question carefully. Then we're just going to break it down sentence by sentence and use it as directions to fill in this graph with a situation. So it says click twice to plot a segment. Click a segment to delete it. Okay. So let's just read it through once together. All right, just to get an idea of what all is going on, and then we'll break it down sentence by sentence, and as we go along, we'll fill in the graph. One spring day, Riley noted the time of day and the temperature in degrees Fahrenheit. Her findings are as follows. At 6 a.m., the temperature was 58 degrees Fahrenheit. For the next 6 hours, the temperature rose 2 degrees per hour. For the next 5 hours, it rose 1 degree per hour. The temperature then stayed steady until 6 p.m. For the next 2 hours, the temperature dropped 3 degrees per hour. The temperature then dropped steadily until the temperature was 63 degrees at midnight. On the set of axes below, graph Riley's temperature data. Okay, so we're measuring temperature in degrees Fahrenheit and time in hours. Okay, so let's take it from the top. At 6 p.m., the temperature was 58 degrees Fahrenheit. For the next 6 hours, the temperature rose 2 degrees per hour. Okay, so for 6 hours, the temperature goes up 2 degrees per hour. How many total degrees will it go up in those 6 hours? If it's going 2 degrees every hour for 6 hours, 12, right? So we're going to start at 6 a.m. Let me just write that down. At 6 a.m., it's 58 degrees. And then we're going to add 12 degrees. So that would make it a total of what, 70? Now, what time, when it's 70 degrees, what time is it going to be? Well, 6 a.m. is when we start for the next 6 hours. So if we add 6 hours here, what time is it? 12 p.m. So that's our first line. We're going to go from 6 a.m., 58 degrees, 12 p.m., 70 degrees. Okay? And that would bring us to here. Okay? So let's just do that part. 6 a.m., 58 degrees. There's 55, 56, 57, 58. And then at 12 p.m., we're going to go up to 70 degrees. Okay? And that's basically up 2 over 1, up 2 over 1. We're going up 2 degrees every hour. Okay? Any questions so far? So we got that. Let's go back and read the next sentence. For the next 5 hours, it rose 1 degree per hour. Okay? So for 5 hours, it goes 1 degree every hour. Right? So how many degrees total do we go up in those 5 hours? It goes up 1 degree every hour for 5 hours. 5. So this time we're going to add 5 degrees. 75. It's going to be 75 degrees. And didn't they say for the next 5 hours? So we're going to add 5 hours to 12 p.m. What time is it now? You're at noon, 12 noon, and you add 5 hours. 5 in the afternoon. Okay, so at 5 p.m., it's going to be 75 degrees. Let's connect that. So you see, you just take it step by step, and it's not so bad. So we want 5 in the afternoon, and we want it to be 75. Well, 75 is way up here. Oops, connect. There we go. Yep, that looks good. So far, so good. Everybody with me? Maybe some of you are ahead of me. Okay, excuse me. The temperature stayed steady until 5 p.m. for the next 2 hours. Oh, okay. Well, let's just do that part. The temperature then stayed steady until 6 p.m. What does that mean? Stayed steady. Stayed the same until 6 p.m. Well, if we're at 5 p.m., isn't that just 1 hour? So for 1 hour, it stayed the same. There. So we took care of this part. So it's still 75 degrees at 6 p.m. Then it says, for the next 2 hours, the temperature dropped 3 degrees per hour. So 2 degrees per hour. How many degrees did it drop? 2 every hour, but how many degrees total? Well, what's 2 times 3? 6. Right? It dropped 2 degrees every 3 hours. I'm sorry. For the next 2 hours, it dropped 3 degrees. So 3 times 2 is 6, but it's dropping. And so that's going to be 69 degrees. How many hours do we add? It said for the next how many hours? 2 hours. So, oh wait, it's not. We should fix this a little bit. I'm going to add this 6 p.m. It was still 75 degrees. I almost forgot. I should write that because I want to take away 6 degrees here, 69 degrees, right? But I want to add 2 hours to 6. Or 2 hours, not 2 p.m. So 8 p.m. Okay, so at 8 p.m. it's 69 degrees. Another way to do this is go down 3 degrees every hour. So you're here and you go down 3 degrees, down 3 over 1, down 3 degrees over 1. So you're there and then connect it. So you could do it that way. Just follow what they say. Dropping 3 degrees over 1 hour, drop 3 degrees over 1 hour. And that should put us at 8 p.m. Let's just double check. Yeah, that would be 8 p.m. And if we do it correctly, it's 69 degrees. Perfect. Okay. So then what happens next? We're here. The temperature then dropped steadily until the temperature was 63 degrees at midnight. So the temperature dropped steadily until it was 63 degrees at midnight. So how are we going to do that? What happens at midnight? Which is what temperature? That's not what I'm reading. The temperature dropped, so it's not going to stay at 69. It's going to drop until the temperature was 63 degrees. So let's find 63 degrees. 60, 61, 62, 63. And at midnight, it was 63 degrees. I think that's midnight. I'm going to just enlarge this because it's easier if I zoom this out. Much better. Okay, here's 60 degrees, 61, 62, 63. So there's 63 degrees and midnight, and we connect it to this. So it drops steadily. So basically, it was dropping at this rate. Okay, until we're there. So this is what they said. It dropped steadily until it was 63 degrees at midnight. I'm just going to double check, make sure I'm at 63 degrees. Yes. Okay. So is anyone working on this one? Everyone done with that? Okay. Has everyone submitted it? Did we get it right? Yay. Okay, let's submit it. Okay. So, okay. I'll show you at the end what it should look like. Okay. So you get two opportunities, right? So just back out and come back to it. Let's try the second one. Example 2. Okay, the example 2 is a little different. It says Javante left his house at time 0 and drove for 5 minutes to the store at a speed of 2 blocks per minute. Then he stopped and went into the store for 2 minutes. From there, he drove in the same direction at a speed of 7 blocks per minute until he got to the bank, which is 14 blocks away. Okay. From there, he drove there until he got to the bank, which is 14 blocks away from the store. Okay. He stopped at his bank for 6 minutes. Then he drove at a speed of 4 blocks for every minute until to make a graph of the, okay, so we got to make another graph. So let's just take it step by step. Log out and log back in. Okay, 1 second.
Send them at the end.
Okay. So we're going to start at time 0 and for 5 minutes, 2 blocks per minute. So we're going to start here, 2 blocks every 1 minute. So you go up 2 blocks every 1 minute. That's 1 minute. Up 2 over 1. That's 2 minutes. So we're going to start here at 0, up 2 over 1. Up 2 over 1, that's 2. Up 2 over 1, that's 3. Up 2 over 1, that's 4. Up 2 over 1, that's 5. So you could do it that way, or you could just say 2 times 5 is 10. So at minute 5, you should be 10 blocks away. Okay? There's 2 options for you. Then he stopped and went into the store for 2 minutes. So for the next 2 minutes, what do we do? What's our distance from home? Does it change? Does it increase or decrease?
It stays the same.
So there. Distance stayed the same for 2 minutes. Okay, that's when he was. So at minute 7, he's still 10 blocks away. Okay. From there, he drove in the same direction at the same speed for 7 blocks per minute until he got to the bank, which is 14 blocks away. Okay. So he went 7 blocks every minute until he was 14 blocks away. How many minutes did that take? 2. Yeah. So in 2 minutes, he went a total of 14 blocks from here. Okay. So you can go up 7, 1, 2, 3, 4, 5, 6, 7, and over 1. You did that in 1 minute, and then you go up 7 more from there. Actually, let me connect those. And then up 7 more. 1, 2, 3, 4, 5, 6, 7, over 1. So there. He covered 14 blocks in 2 minutes. Okay, going 7 blocks per minute. Okay. What happens after that? Help me out, guys. So he's at the store. He stopped at the bank, or he went from the store to the bank. He stopped at the bank for 6 minutes. So what do we do for 6 minutes?
Stay steady for 6 minutes.
Yeah. So let's just count it over 6 minutes. 1, 2, 3, 4, 5, 6. So he stayed that long for 6 minutes. And then the last part. Then he drove home at a speed of 4 blocks every minute. 4 blocks every minute. So you can count down 4 over 1. 1, 2, 3, 4 over 1. Down 4 over 1. Or what height are we at? How many blocks away are we at this point? 24. How many 4s go into 24? 6. So what you want to do maybe is count over 6 minutes. 1, 2, 3, 4, 5, 6, and then just bring that all the way down. It took him 6 minutes to get home, basically. Or you can count down 4 over 1. Okay. So we're here. And so would be there because that would be 6. 1, 2, 3, 4, 6. So he went down 4 over 1, down 4 over 1. You can just keep on doing that or figure out that it's going to take him 6 minutes to get all the way back home, which is there. Okay. So that would describe this. So did we get it right? Yeah. Okay. Here we go. Submit. And you'll be glad to know these are the toughest ones. We just did the hardest part of this whole assignment. Okay? And
like the same way you do with IXL, like do you round? Like if we get 95%, will you do the same?
yeah. Okay, so you got graph stories. These are pretty good. They're not too bad. Let's do examples 3 and what says 3 and 3? Miscounted there. We'll do 2 3s. Example 3, number 1. So basically they tell you a story, they describe a graph, and then they make the graph. So this is one spring day, Christopher noted the time of day and the temperature in degrees Fahrenheit, and they describe it. So it looks like the temperature increased and then increased at a faster rate, stayed the same, and then declined at a faster rate. Okay, so let's see what the question is. Which of the following statements is true of the temperature at 1 p.m.? And let's just look over the questions. Let's see, 1 p.m. is here. So it looks like the temperature was about 68 degrees at 1 p.m. Temperature was 68 degrees at 1 p.m., but they're asking about the rate.
That's 58.
Or 58. I'm sorry, 58. The temperature was 58 degrees. Let's figure out the rate. How fast is the temperature rising? Let's count over. So it went up 1, 2, 3, 4. It went up 4 degrees in 1 hour. Check my math. I'm going from here to here. I'm just figuring out the slope. I want to go from here to here because those are 2 points where the graph crosses perfectly. 4 degrees in 1 hour. Would you agree with that? Is it going up 4 degrees in 1 hour?
Yeah.
Okay. So we're looking for something like that. Temperature rising 4 degrees in 1 hour. Which is our choice for that? Bottom one. Yeah, it's not dropping at all. So you could just say it can't be second one, can't be third one. It might be the first one, but that's actually the reverse of what we want. It was rising at a rate of 4 degrees for every 1 hour. Boom. All right. Let's try number 3, the second one. Okay, so now it deals with falling snow. Snow on the ground, so it looks like we had a snowstorm. Then it stopped snowing, and then it started snowing, but not as much, at a slower rate. Okay, so let's see what it says. At what rate was the snow falling during the first snowfall? 5 inches every hour.
5 inches every hour?
Yeah, I think you might be right. Let's just pick 2 points. This is a good point, and this is a good point. And 2 inches every 1 hour, yeah.
Wait, why is it 2?
It's going up 2 inches every 1 hour.
It said at the first snowball.
Yeah, this is the first snowfall. Then it stopped snowing, and then this is the second snowfall.
Oh, I thought it said snowball.
So this is definitely the first snowfall, and it's 2 inches every 1 hour.
So you don't start directly at the first one. You start at 0 because that's where.
I just picked 0 because that was a good point. I could have started at 1 hour, and I would have gone up 2 and over 1, and ended at 2 hours. You just pick 2 points where it crosses nicely. All right. So you'll have 5 questions like that on interpreting the graph stories. And then let's go to the last part, which is select graph match story. Example 4. Okay. So let's look at it says match the correct graph to the story. A bunny rabbit has a baby bunny. Oh, that's nice. A month later, each bunny has another bunny. Oh, gosh. And a month later, each bunny has another bunny, etc. So this is growing exponentially, very quickly. And before you know it, you have a lot of bunnies. So which of these graphs would describe that? A, B, or C, or D? Do you think A makes sense?
Yeah.
It goes up, and then, but how? It goes up, then down, then up, then down.
Why would it go down?
Yeah, nothing in here tells us that it's decreasing in the story.
It's C.
Yeah, it can't be B. Looks like it should be C. Let's just look at D real quick. Well, D is decreasing. The only one that makes sense is this one. Yes. So let's go with C. Although realistically, it would go down because your resources would run out, right? And you can't feed all those bunnies. All right, let's do the next one. Example 5. Let's see the situation. Oh, we did this one already. Uh, match the correct graph for each story. You ride a Ferris wheel a few times. Which graph matches that? Remember we did this in the Kahoot? Which height versus time matches that? A, B, C, or D? If you're riding around a few times. A. Although A is a little wrong, remember? Well, you start on the ground, right? You get on the Ferris wheel, you go up, you go down, but you don't get off the Ferris wheel, then get up again, get on again. This here, it should be a little above the ground. But we're not going to argue with them. I think they want us to pick A. That's the best out of all these choices. Hmm?
So it's wrong? Like...
The graph is technically a little incorrect. You don't hit the ground again when you're on a Ferris wheel. That would be bad. Unless you scrape the ground. Example 6. A golfer hits a golf ball. Think about the height over time for a golf ball.
Well, I mean, it really depends on how you hit it.
Well, let's assume they know how to hit a. They didn't hit it so it rolls on the ground. I've done that a lot of times. Golf is a frustrating sport, folks. Which of these best?
C or A?
C or A? I think C. It would be the motion would the graph of the motion would describe even how it looks physically. So yeah, I would go with C. It's not really linear, it's more curved. Okay, last one. Number 7, which should be 8. A parking garage charges a fixed amount for each hour or every portion of an hour. So if you say an hour and 15 minutes, they're going to charge you for 2 hours. They'll charge you this much, then the next hour they'll add some more, then the next hour they'll add some more. No partial money. Okay. So which of these graphs best describes how they charge you, the cost over time?
B?
B? Well, looks like they don't charge you, then they start charging you after like a couple hours. That'd be nice, but that's not what they're doing. I think it's A. For the first hour, you pay this much. For the next hour, it jumps up to this much. No matter how much far you, then it just keeps on increasing.
Why aren't they connected?
Because you go to the next amount. So this is they call it a piecewise function. We haven't seen too many of these. So yeah, I think it's A. This one's declining. Here the price would go up and down. So definitely A makes the most sense here. Okay. So that is the last one of these. And we picked A for that last one. So go ahead and start wherever you like. If you want to work your way up to the harder ones at the end, that's fine. You got 10 of these select a graph matching, 5 where you're interpreting the graph stories, and then 5 where you're making the graph yourself. Okay? So go ahead and work on that, and it's due by tomorrow.